We're going to do 10-3 first. The first part of 10-3 is sector area. Like I said, we're not doing arc length because we already did arc length. Okay, in 10-2, I think. All right, so with sector area, it means I don't want to find the area of the whole circle. I just want to find a piece of it, okay? I don't want to find the area of the whole circle. I just want to find a piece of it. So it's called a sector, all right? So to find the sector area, the formula is A equals pi r squared m over 360. M represents the measure of that central angle, okay? And then the radius, of course, is the radius. The r is the radius. We're also going to talk about segments of a circle. With the segment of a circle, it's like this little piece right here. So I don't want to find out the whole sector. I just want to find a little piece of it, and it's called a segment of the circle. To find the area of the segment, I have to find the area of the sector and then subtract the area of the triangle. Okay? Kind of like composite figures. So let's look at number 1. It says find the area of each sector, give your answer in terms of pi, and round to the nearest hundredth. So I'm going to use this formula here because it's asking me for the sector of a circle. So A equals pi, what's my radius? 6 squared times m, what would m be? 70 divided by 360. So I'd put that in the calculator, round it to the nearest hundredth. So pi times 6 squared times 70 over 360. And what do you get? It says round to the nearest hundred, so it'd be 21.99 centimeters squared because it's area. Okay, sector area here. So we're going to use the formula A equals pi. What's my radius? 9 squared times, what's my m? 120 divided by 360. So I put that in the calculator. And what do you get? 84.82 inches squared. All right, so now let's look at number 3. It is the area of a segment, not a sector. So what you do is you find the area of the whole sector first and then subtract the triangle from it, okay? So we're going to use 2 formulas. We're going to do pi for number 3. Pi r squared m over 360 minus, how do you find the area of a triangle? 1/2 base times height.
What if it's a square?
What if what is a square?
What if the circle's a square instead of triangle?
All right, so what's my radius of the circle? 2 squared. What's my measure of my central angle? 90 divided by 360 minus 1/2. What's my base and height of the triangle? 2. Okay. So I have 4 pi times 90 divided by 360, which is 1/4. Minus 1/2 of 2 is 1. And then 1 times 2 is 2. So minus 2. It's still area, so it's inches squared. Okay, number 4. Same formula. What's my radius of my circle? 8 squared. What's my measure of my central angle? 60 divided by 360 minus 1/2. What's my base of the triangle? How you know it's 8? How do you know the base is the 8? How do you know it's equilateral? It's only one angle that's 60 degrees, so how do you know it's equilateral? How do you know that it's 60, 60, 60? I can divide 60. I mean the leftover 120 up and not be 60 and 60. Okay, so LK is what kind of segment? That's my radius. And what about LM? So how long is LM? So that means this side's 8, right? So then what do I know about this angle and this angle then? That's not what I asked you. What do I know about these two angles? That they're equal because these two sides are equal, right? So that's why I know that these will be 60, because once I do 180 minus 60 and divide by 2, these will be 60. But y'all assumptions on how y'all reasoning was flawed. It doesn't have to be 60. The reason I just gave you is the reason why it's 60. Okay? Alright, so my base is 8. Because all my angles are the same, so all my sides are the same. What's my height? Did they give me the height? No, remember your height and your base must make a 90-degree angle with each other. If you don't have a 90-degree angle in that triangle, you don't have a base and a height. Okay? So, bringing it down, I'm just drawing it on the outside, okay? So this side would be 8. This side would have been 4, because it's half of 8. So how can I find out this height? I can use Pythagorean theorem. I could have used trig. I could have used special rights. It just depends on what you want to use. I think I would use special rights because this would have been 30 up here, because it would divide the 60 up. And this would be 60. So with a 30, 60, 90, and if you actually learn the formulas, I wouldn't even write all this. I would have known that what my other side is automatically because I know the formulas. So notice that the 4 is across from the 30, right? So that means x equals 4. So the side across from the 60, which is the side I want, is x squared root of 3. So instead of x, I could put what? 4. So it'd be 4 squared root of 3. That'd be my height. And then I don't have to worry about rounding, trying to make sure I put it in the calculator correctly or anything like that. So that's my height. So then I can put all that in the calculator. So 64 times pi times 60 divided by 360 minus 16 square root of 3. And y'all should have gotten what? 5.79 with a 7 behind it, so it'll be 5.8. Okay, let's turn the page. 10-3 study guide intervention is what we're doing next. Okay, so remember I told you all circle stuff is new. You have to go back over it. Me just reading it to you now, me just going over it with you now is not enough for you to remember it. Okay? I don't even remember it that way. I got to go back and do my practice and stuff so I can remember how to do circles, because circles is kind of by itself. Okay? All right, so this one, the rule on this one is that points on the circle determine both chords and arcs. Several properties are related to points in a circle. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So here on this example here, you see how they have these two arcs are congruent, right? So since these two arcs are congruent, that means these two chords are congruent. And vice versa. That's what they're saying. Okay? So like on number 1 here, you see how this chord SR is congruent to ST, right? So that lets me know that this arc out here is equal to this arc out here. That's what it tells me. Okay? So I know that the arcs all together would equal how much? The arc around the whole circle would be 360. So what would I do to figure out what these two arcs equal? I will subtract 64 from 360. And then what? Divide by 2 because they're equal. So that means x would equal how much? 148. Okay, again, you see how this chord FG is equal to DE, correct? So that means this arc here is equal to this one here. So this one is 116 over here, so that means that this one's 116 over here. And then remember that this is what kind of angle here? What's it called? A central angle, and central angles are equal to the measure of their arc. Okay? So that means that x equals 116. With circles, it's not hard problems. It's just that you have to remember the rules. If you don't remember the rules, then it seems hard. What would be my answer to number 3? 82. What would be my answer to number 4? Okay, so I heard different answers. So I'm going to just make sure everybody understands how you get 135. Remember, it's only 3 arcs right here. It's one here, it's one here, and then it's one here. Realize they didn't do the tick marks this time, but they told you that the two chords were 9. Is 9 equal to 9? Okay, so that means this arc is equal to this arc. So you just should have done 360 minus 90 and divided by 2, just like we did this one. So x equals 135. What about number 5? How would you set up number 5? 2x plus 4 equals 18. So then I will subtract 4. So 2x equals 14. So x equals 7. This one, how would you set up number 6? 2x plus 1 equals 5x minus 5. Subtract the 2x. Add the 5. Divide by 3. X equals 2. Okay. Any questions about that? Make sense? The two bottom ones, with the 3 bottom ones there, no, not that one. These are the same thing. It's just that they're in different circles. But notice that they say here my arcs are equal. So that means this chord is equal to this chord. Okay? So it still does the same thing. All right? And that's only if the circles are equal. So notice right here that they said circle M is congruent to circle P. All right? Let's go over here to the 10-3 arcs and chords. The second part of it. Okay, in a circle, if a diameter or radius is perpendicular to a chord, what does perpendicular mean? It makes a 90-degree angle. So if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. What does bisect mean? Cut into 2 equal pieces. Okay, cuts into 2 equal pieces. In a circle, the perpendicular bisector of a chord is a diameter. So this is just saying the converse of this. It's saying if they didn't tell you it was the diameter or the radius, but it bisected it, then you should know it's the diameter or the radius, okay? In a circle, or congruent circles, two chords are congruent if and only if they're equidistant from the center, okay? So, if I tell you that OX and OY are equal, like they're the same distance away from each other, then you should automatically know that this chord is equal to this chord. Okay. All right, so let's look at some examples. Number 1. In circle P, the radius is 13 and RS equals 24. Find each measure. So the radius is 13. Do you see a radius on here? QP is my radius and RS is 24. So since QP is my radius, what is RT going to equal? 12. Because the radius or the diameter would bisect the chord. So this is 12. This is 12. So then it asks you to find RT. RT. Oh, we already did that. 12. And what about PT? Anybody have an idea to figure out PT? 13 minus 12? Alright, so let me ask you this. If I make a line here from R to P, how long is that? How long is RP? 13. But why? Because it's a radius. So then what could I do to find PT? I could do Pythagorean theorem. So I'm going to do 13 squared minus 12 squared. I'm not going to write it down. 13 squared minus 12 squared, which is 25. And the square root of 25 is what? 5. So PT is 5. So what is QT? Huh? Not 13. 8. Because remember, from P to Q is the radius, that's 13. So if you subtract the 5 from it, then this part has to be 8. Okay. Even though we're dealing with circles, Pythagorean theorem and trig and special rights don't go away. Okay. All right, let's look at 4. It says in circle A, the diameter is 12. CD equals 8. So what does CF equal? 4. And FD equals 4. And then arc CD equals 90. So then they ask for arc DE. What would arc DE equal? 45, because it bisects the arc and the chord, remember? How long is FD? 4. And how long is AF? So we're going to have to bring this radius down again, right? And this, how long will my radius be? 6, because it'd be half of 12. So we're going to do what to figure out AF? Pythagorean theorem. So we have 6 squared minus 4 squared. It gives us the square root of 20. Does it tell us to round? Yeah, to the nearest hundredth. So 4.47. Questions about that? Okay, let's look at number 7. TS is 21. UV is 3x. What is x? So how would I set up number 7? Notice that they are equidistant from the center. That's why they gave you both of those a 6. So what should you know about TS and UV?
They're equal.
They are equal. So 3x equals 21. So that means x equals 7. Okay. Any questions about that? All right.